Calcs.com. Go there and create an account. Basically what it does is it handles all of your with the right units at the end of everything. So I'd really suggest that program, and that is what we are going to be using. Oh, here it is. Huh. Interesting. Apparently I did something with the drive gear, then now the drive gear has some images on it. Anyways, so let's go back to what we're doing here. It has the same stuff on there. I don't remember that stuff being there, but anyways, we're gonna jump to the most recent sketch, and we're gonna edit sketch. Okay, so we're gonna have two gears. All right. So basically how gearing works, like I said, is you want to use the contact area and the contact point. What you could think of it as is 2 pi r, right? 2 pi r, which is the distance that this travels. So the distance that this travels is, let's say, it's going to turn this gear the circumference of this circle, right? Which is 2 pi r. So 2 pi r is the distance, or you could say pi d, because 2 times r is the diameter. So if this rotates once, which is pi d, which is the circumference of the circle, it's going to turn that circumference, right? And then the total needed to turn this completely is, let's say, 2 pi r2, I guess, or pi d2, right? And so basically what you could think of is it's the gearing ratio is pi d1 over pi d2, right? And basically the pi's cancel out, so you're left with d1 over d2, right? So the difference in the diameter is the gearing ratio, and then obviously you multiply that by RPM or RPS, revolutions per second, or revolutions per minute, or whatever. So what we need to do is, in SwiftCalcs, we need to build a solver that will determine these two gears to get this, and basically determine if we need 1 gear, 2 gears, 3 gears, or however many gears between these 2 points. But the distance between these 2 points is this, 3.279, right? That's the total distance. We can make that bigger, but that's the total distance, 3.279 inches. So now that's a total distance that we have. So, and basically this is very similar. It's weird. It looks like it wants total distance equals 3.27. There we go. Inches. Okay. And you see there, basically, if you hit the colon, or the parenthesis, it basically creates, you could do a fraction or whatever, and so at the end of everything, it'll check our units, and at the end we should see the right units that we want. Okay, then next we're going to create a slider. So variables, and then there's a input slider. I'm going to drop the input slider in there, and we're going to call this number of gears, and this we're going to make the maximum value about 4, minimum value 1, step value 1, and this is unitless, right? So number of gears, we have distance, number of gears, and I guess, and basically what we would do is we would probably turn this knob until this is big enough to work, pretty much. To where this shaft, where we'll work with this shaft here. So that's good, that's good. Total distance, number of gears. Okay, now pretty much what we need to do is, let's say we have here, let's put in another slider. We need input RPM, and here we're gonna say this to 1,000, and then we're gonna go here. It even has RPM, revolutions per minute, step size 1. It doesn't exactly work at step size 1, but you can see it's okay. And obviously minimum is probably 3. And then here we want, I'm pretty sure I talked a little bit about SwiftCalcs in one of my other videos, but it's an amazing tool. I use it a lot. Like 5 RPM, and then we want 30. 30 is output RPM. So then we have gear ratio again, and it tells you what it is. Oops. And then we go here to tell it that we want. So yeah, we could do a program here, but I never done this part before, because we're gonna have an issue with the number of gears. So what we'll have to do is we'll have to probably manually program that in to have the different options of gears. So let's see if 2 works for right now. So I mean, we're just gonna put 2 here, but it's probably not gonna be relevant. So first one has to be a minimum of, minimum diameter is basically this. It's a 1/2 inch, so 0.5 inch. Okay, so first gear minimum diameter, and we have the total distance. Bump that up to this size here. This is 1 inch. I'm gonna say first is 1 inch. Okay, first gear minimum diameter is 1 inch. So the first, so I'm gonna say that first gear obviously is spinning at 600 RPM, 602 in this case, and the second gear, and then what I'm gonna put here, total distance, and I'm gonna say final gear. And final gear is, so technically this is 3. But final gear, oops, is this last gear, right? Which is 2.5 inches. So this is 2.5 inches, 2.5. Oops, final. So first gear 1 inch, and then obviously the difference between the two is the gear ratio. So now basically what we need to do is, okay, so how do the gear ratios add up? So let's write an equation for that. What are you doing with my pen? It's right here. So if we have 3 gears, let's say it's pi d1 so this is a 3-way ratio. So basically what I'm going to say is pi d1 times RPM 1 equals pi d2 RPM 2. Well, basically we know that it should be d1 over d2 over d3 should equal, say, and the last one's 2.5. So that's 1 over 2 over 2.5. Don't remember my calc now, but divided by 2.5. No, because it's got to go again. So pretty much what we could do is we could do a cascading. So we could do 1 divided, so d1 divided by d2, d1 divided by d2, and then 3 in parentheses. So what we could do here, and then but we need to fill this in, so that even we have d3, so we need to solve for d2. So first we do 20.066 times d3 sorry, it's not D1. Yeah, so it's D1 divided by D2, D1 divided by D2, and then times D2 divided by D3. So, but then D2 cancels out though. That can't be right. No, it has to transfer the energy from one to the other. It has to transfer the speed. D1. So D3 is going to be bigger than D2. Because it's going to be, yeah, so that should be right. But because it's going from D3 to D2, it's D1. So let's do some math here. So let's say D2 is 2.5, D1 is 1 inch. Sorry, D2 is 2 inch. D3 is 2.5 and 2 inch. All right, so it's 2. It's 1.1 times 2 equals 2.2 times. Man, this thing's gonna have to have a massive you know what? This thing's probably going to have a massive tooth for a chain. That's probably what I'm going to have to do. The thing's going to have to be 20 times bigger. So this thing's going to have to be really, really small. Because otherwise, let's say that this thing was let's say that this thing was 60 RPM or something. So 60 RPM means that it's doing a cut, and in order to get this with that gear, to get it down to 20, it needs to 20 times. I mean, if this is 1 inch, this thing has to be 20 times 1 inch, so that's 20 inches. So how big is that? 20 inches is big, right? It's a big gear. It goes over the top of the other gear. And obviously the gears, I'd probably just have one gear here, but it would be nice to have a gear here and a gear here. Because really the only other way, so 1 inch. Yeah, because I don't think having an intermediary gear here is going to do much. Yeah, I think it just cancels out. Sorry, the actual, circumference. So pi d is equal to, first one, let's do, for gear 1, let's say it's 1 inch. So that is 3.14, right? So 1 diameter times pi is 3.14. Second one, 2 inches, so that's 2 times pi equals 6.28. And last one, 2.5. So 2.5 divided by, sorry, 2.5 times 3.14 equals 7.85. Okay, so the difference between the first one and the second one is 6.28 divided by 3.14 is 2, right? Obviously. it doesn't do anything. And then what if we had a longer gear train where there was more than that? So let's say there's D1, D2, and the difference between D3 and D2, and the difference between, let's say D3 and D4. So now, yeah, basically D3 cancels out, D2 cancels out, so now it's the difference between D1 and D4. Okay, so basically there's only one gear. Unless you go up, it looks like, because then how do the gear trains work? Right, I mean, so here's kind of a basic, so this is turning, once, and this got turned about 3 times. Let's see what else. This is another way of doing it, some sort of pinion gear. Obviously this is going to have to be a machine, which is very difficult, but this thing could be really, really small and possibly work. So some sort of worm gear would work. Or a ring gear. Ring gear would be interesting. That would also work. But I have to be coming from the side, pretty much. Or even this. This is kind of interesting gear here. Well, basically what this is doing is that when you do this, this is going to rotate at a different RPM, right? So this is going to reduce by a little bit, and this one's going to be even more reduced, but it's basically the difference between the starting gear and the ending gear, but this can't be continuous. That's why they don't have an intermediary gear on a bike, I'm assuming. So, do we have any other options? 600 RPM is too high. So the lowest that we can get is we cut it in half, cut it down 300, but it's still 600 cutting each time. Basically 4 inches. Right? Maybe like 4 1/8. Yeah, so 4 1/8 versus 1 inch. So that's 4.15 times lower. 4.125 divided by 600 divided by 4.125 is equal to 145 RPM times 2. That's about 300 RPM pretty close to 300 RPM, or 300 times cutting per rotation, which I still think is too high. We need some way of dropping this RPM down by even more. Let me see, do we have an off-the-shelf? Because the other thing that we could do is we can move this thing back. So we could somehow make an adapter here and send this into a planetary gear set before we send it back over here. I mean, we could have this thing back over here somewhere. Off-the-shelf planetary gear set. $10 to 1. We need a very large. Well, it's pretty close. So let's look for a 20 to 1. Well, 10 to 1, we can make that work, because then we just do 2 to 1 here, right? We basically have to put this intermediary gear, and it's going to cost us extra money. 2-inch gear. Where'd that go? So yeah, something like this would be interesting. Nominal output torque, 44 inch-pounds. Yeah, we're doing way more than that. Five to 1. These are expensive. Alright, well, let's go to China and see what we got. Holy. Yeah, let's check this. Newton meter. I think that's still pretty. Newton meter for pounds. So this is. What the heck? Anyways, do they have a minimum? Well, that's interesting. I mean, I'm gonna get tariffed up the wazoo for it. Oh, this is a. I just want something like that, just a regular DC motor. Ratio, okay. Low noise, okay. Blah 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 blah. Worm, oh, it's a worm gear, okay. I mean, I would rather not use worm gear, but whatever. Input, we want it to be about, ooh, 2 horsepower would be nice. Okay, here we go, what do we got? Hull, shaft, and then this has got to be transmission ratio. Where are these referring to? Well, this is pretty interesting. So yeah, it's chromium, magnesium, titanium. Okay, so it looks like they're doing a lot of worm gears. Newton meter. So let's double this. So it needs to be like almost 500 something. Oh, no, 400. Yeah, about 350. Output shaft, kilograms force, gear reduction. I don't know what that means. Range of output. This is just inertia. Yeah, so something like this would be nice. But it probably needs a small shaft. It's weird. Thank you so much for watching. I'll see you guys in the next video. Take it easy. Peace.